Dr. Knack.
Dr. Bilo.
TU Delft, Green Village. This is kind of like Area 51 of sustainability, all the different houses here. Tell me what we're doing here.
Super interesting, super interesting. They have a lot of new developments, a lot of really impressive concept buildings. Some of them are solar decathlons. Delft had 3 entries in the solar decathlon until now. And we're going to see some of them. And we're actually going to talk to Andy van Doppelsteen, Professor Dr. Andy van Doppelsteen. He's a sustainability professor in the faculty. He's also heading the sustainability activity of the university, the campus.
Yeah.
And he has a lot of knowledge about sustainability, energy and circularity and how to prove this to buildings.
Yeah, no question, the go-to guy if you want to talk about...
The go-to guy at the Area 51.
Perfect. Hey!
Hey Andy!
Herr Professor Knack, hallo.
Professor, Herr Doktor. Sustainability, circularity and energy.
Yes.
Why is this important?
Why? Because we are running out of resources, that's one. 2, because climate change demands us to act and to make big changes in the carbon emissions from the built environment. And why facades? Because facades play an important role therein, in the use of materials, but also as the intermediate between inside and outside. So the facades are the skin of a building and therefore very important about the interaction.
Can they, I get that, can they also be part of harvesting energy?
Of course. I think they need to be, because until now we've used the building skin too little for other means than just keeping out the rain. They should also become much more productive. They can be air purifying, they can produce a lot of energy. They can also absorb rain and store it. So I think facades could be much smarter than we do right now.
Okay. And when we think about a building design and you're a facade engineer, what aspects do you have to take care of in the means of circularity, energy and sustainability?
I think you need to take into account, of course, which materials you use. They all need to be circular in the future, so they either have to be technical, they can be recycled, reused as much as possible, or they are bio-based, and I think there's a big future for bio-based materials there. And then, the skin, it needs to interact intelligently between inside and outside. So they need to create the right indoor conditions by being the exact perfect element that touches upon the outside. So it should play with the sun, it should play with light and rain and energy production and breathing perhaps even. So the skin should be much more intelligent than we have used to do. Yeah.
You used to do, which brings me to say the next theme to address, active versus passive systems. Passive systems in the means of it's the skin, you can may open the window, versus active systems which can do something else. What is your, how do you see them and what's your preference?
I don't have a clear preference between the two, because I think you need a bit of both. Passive skins that have been well designed, that are well oriented, that have the nice details to keep out, for instance, the sun in summertime, but admit sun in wintertime. Those can be passive elements. But I believe in the transition we are making now, we need to go further than that. So we need technology to make building skins more intelligent, to make them more productive, and to also to get to the amount of energy production that we need. Completely passive skins are nice in a low-tech society, but we need a lot of electricity nowadays. We need hot water, and a passive skin doesn't produce that. So I believe that it's going to be more active rather than less.
So a combination, more active than passive. Now to the solar decathlons, which we see around here, several of them. How did you define what type of building envelope, what type of facade was necessary?
In general, we have the so-called new step strategy, by means of which we approach the building design, meaning that you first think about how to reduce the demand in existing buildings, The second one is to make optimal use of waste heat, of residual energy. And the last step is to produce energy in a renewable way, in a sustainable way. And so the way we approach the building behind me is first to have a look at what are the options to add post-insulation. Then, of course, heat recovery from ventilated air was important, but also we already thought about bringing in air through the ground, through the soil, to have it preheated in wintertime and pre-cooled in summertime. And that is also a means of using your environmental energy. And the last step was renewable energy. And of course, solar panels are a logical solution, but in this case, it's a very smart solution also for heat. So the glass house you see behind me, it captures solar heat. Heat rises, so it ends up between the two roofs. And then there's a heat exchanger that is connected to a heat pump system. And the heat pump creates water of 55 degrees for showering, but also for the heating system. So I think that all in all makes it a completely energy neutral building that is also very comfortable. And I think that's one of the examples.
And when you see this system where you have this addition of this winter garden to an existing house, which we call facade, which acts as an active facade, what would you advise to take care of? Where do things normally go wrong when you design this kind of things, when you build this kind of things?
Of course, one of the main things when you talk to people about this is about cost. How much does it cost to make it? And the example we have here, I think it's a little bit over-dimensioned, so it's too heavy for the function it has. And that, of course, means that it's a lot of investment also that can be lower. So thinking smartly about money, but looking at it from a long-term perspective. So it's an investment that you make and you save energy in the end, because this is a zero-energy house, so it doesn't have an energy bill. And if the system can last 25 to 30 years, then there's no problem. Then everything will earn itself back. But it's the pre-investment that is needed that is usually a problem. So if you can come up with a solution that is as simple as possible, I think that's the best one. Because simple solutions are usually also cheaper and easier to achieve. Technically, there's not much wrong with the solution we found here. It's quite simple. Of course, it's quite an investment to make such a structure against an existing house. But it's possible. These things can be easily engineered.
It's an interesting comment by a technology professor talking about the main problem in finance and not in technology.
Yeah.
I think you hit the point, don't you?
Yeah, we know we can solve things technically. I'm not afraid of that. But in practice, it's two things that are really a problem. Either it's the willingness to pay for it in the investment, and that willingness is the second one, because many people and political decisions, they are usually opposed to what is possible. But actually, here in Holland, we have enough money. It's just invested in the wrong things. If we would invest it in refurbishment of houses, then we have plenty of money. That's no problem. But see it as an investment that will earn itself back mostly, not everything. But if you include a carbon price with it, then it even earns itself back.
For sure, then it's worth it.
Yeah,
Okay.
absolutely.
When I look at Dr. Bilo, I think this is...
No, it's a very good start, but maybe a little bit shorter. We aim for 7-8 minutes.
Damn, he wants us a second take. My hand is freezing.
Yeah, but we have to have a second.
You're rolling?
Yeah,
You're rolling.
now also with audio.
Now with... Not really.
You didn't record it.
So it's his fault and not our fault.
But now keep it short.
We have audio of the...
Are you okay with this?
Perfect.
Okay.
No, it's good.
Ciao, man.
Ciao.
Thanks.
See
Thanks,
you.
Andy.
Bye-bye.
Bye.